The Dominion Industry Group is active on all the continents. We've been present in Poland for over 20 years, first as Carena and later as Biroa. We design, conduct investigations, renovate, modernise and implement developments with the so-called turnkey system in accordance with the Integrated Management System, IMS, which our company implemented and uses. Our competent engineers and specialists meet the needs and problems of clients with full professionalism and commitment using the latest solutions and knowledge. To describe our capabilities better, we would like to present one of the largest challenges that our engineers and specialists have faced. Construction of two 185-metre high cooling towers for power units with a total capacity of 1,800 megawatts at the PGE power plant in Opole. The engineers and a team of Biroa specialists started work in August 2014. Preparation of the ground for foundations required replacement of the soil to a depth of over 9 metres. For this purpose, we excavated 57,000 cubic metres. The ring-shaped foundations that will eventually carry the loads of the whole construction have a diameter of 113 metres, a width of 6 metres and a depth of 1.5 metres. The shell supports were made of 36 reinforced concrete columns, each 9.5 metres high. The columns are set with a 16-degree inward tilt. The cooling tower shells were constructed using 50 independently mobile suspended formworks with hydraulic motor lifting mechanisms. This special system was developed by Dominion. During the most intensive stage of construction, there were nearly 200 people working in 2 shifts. A team of construction engineers was responsible for supervising all operations. There were also quality controllers, work safety inspectors and foremen with their own groups. The diameter of the cooling tower shell at the base is 100 metres. In the initial phase, the shells grew upwards at 3 metres per week on average. It's also worth mentioning that each construction ring is 1.5 metres high, with a circumference at the lowest part of the tower of almost 320 metres of reinforced concrete wall. The crane for lifting materials was mounted on a monolithic foundation specifically made for this purpose. The crane was continuously raised and, for stability, anchored with cables to the foundation ring. Ultimately, the crane reached a height of 215 metres. Workers accessed the reinforcement and concreting levels using an external elevator designed to move around the curvature of the cooling tower shell. The cooling tower shell for Unit Number 5 was completed in April 2016. At that time, the cooling tower shell for Unit Number 6, being built simultaneously in the same way, had reached a height of over 20 metres. The towers have 2 tasks. One is to cool the water used by the power units, and the second is to act as chimneys, to discharge fumes which have been cleaned earlier in absorbers. The cooling tower shells have 2 inlet openings for the exhaust gas ducts from the absorbers. The ducts were produced in parallel with the construction of the shells to shorten the total timescale. They are made of fiberglass reinforced plastic and have an internal diameter of 8.8 metres. The top of each cooling tower has a reinforced concrete cornice ring to increase the stability of the whole shell structure. Its diameter is 70 metres. Nowadays, cooling towers are designed in the shape of single-shell hyperboloids. This gives them the right stiffness at such impressive heights and diameters. There are vertical trapezoidal ribs on the outside of the cooling towers to improve the parameters of airflow around them and to reduce the effects of wind pressure. The main duct for the water to be cooled is inside the cooling tower. It's commonly called a riser. Inside the main structure, a smaller one was built to support a reinforced concrete slab at a height of 32 metres. The slab is one of two supports for the flue gas ducts. The second support is at the cooling tower shell. In the foundations, there are two reinforced concrete ramps with a slope of 15 degrees to discharge the cooled water. The entire internal and external surfaces of the cooling tower shells were thoroughly prepared and then covered with a protective layer against the influence of fumes and water. The 54-metre flue gas ducts were transported from their construction site to the middle of the cooling tower. Special low-loader trucks were used during this operation. The flue gas ducts, weighing 130 tonnes each, were raised using two cranes and special equipment, then placed on the concrete slab to project through the shell. The axis of the flues is at a height of approximately 38 metres. It was one of the most complicated and precise activities. After many hours of planning and preparation, it was completed successfully. Our company was also responsible for the implementation of the water distribution system. The supporting structure was designed and made as prefabricated beams, columns and ducts. Inside each cooling tower, we assembled 104 posts, 440 prefabricated beams of various shapes and 4 main water distribution ducts. The so-called riser is located centrally. Its task is to raise the water from 7.5 metres below ground level to a height of 9 metres above. There, the water is divided into 4 main distribution ducts, supplying the individual sections of the cooling system. About 4 kilometres of PVC pipes are installed at the spraying level in each tower. The pipes have various cross-sections and almost 10,000 sprinklers. The whole upper surface of the cooling system has specially profiled sheets to eliminate drift. A cooling water outlet is installed below the cooling tower's ring foundations with a volume of 12,000 cubic metres for each one. At the final stage, special graphics were applied with rainbow, sun and music theme. They were put on the external coatings of the cooling towers and refer to local cultural traditions. The graphics are unique, not only in Poland, but in the whole world. They perfectly fit the traditions of the National Festival of Polish Song in Opole. This visualization was also a demanding logistical challenge because the total outer surface area of both towers is approximately 9 hectares. Silencers are placed around the basin of the cooling towers. This is very important from the point of view of environmental standards and norms. Service access to the water distribution level is via a stairway from the south side and a ladder from the north side. Access to the cooling tower's top is provided by a ladder made of stainless steel with resting platforms every 6 metres. The ladders and railings inside the towers are made of fiberglass reinforced plastic with high resistance against corrosion. The work which Biroa performed was not only the construction work, but also the design, delivery, assembly, wiring, lighting, automation, measurement and control equipment, and finally the commissioning of the cooling towers as a turnkey project. This solution optimizes the entire project process through the selection of appropriate algorithms for technological requirements and the applicable atmospheric conditions. The specialists from Biroa built the 2 cooling towers according to schedule between the summer of 2014 and the autumn of 2017 without interruption. These cooling towers built by our company are among the largest facilities of their type, not only in Poland but also in Central and Eastern Europe. Their height is 185 metres. They will operate in conjunction with the most modern power units, having a total capacity of 1,800 megawatts. The competencies of Beroa engineers, supported by over 100 years of tradition and experience, contributes significantly to environmental protection by implementing modern and innovative solutions. It can be said that we are a reliable partner for our clients and meet their highest demands.